Hello and welcome to another episode from Spiral Physics Education. In this episode we're going to be looking at adding vectors in one dimension, adding vectors in two dimensions, and focusing on how to add these vectors in two dimensions using a scale diagram. What you need to know for this lesson, and what would be really helpful if you understood what scales and vectors are and examples of those, and if you're not too sure about that, do check out other videos on the channel to help you get up to speed on that. So let's start off with adding vectors in one dimension. Now these are very useful when it comes to calculating resultant forces, especially for Newton's first law and Newton's second law questions. And in one dimension we'll be looking at just forces acting in the horizontal plane and forces acting in the vertical plane. So let's have a look at an example. We'll start off with a horizontal force acting to the left, and that's got a force of 15 newtons, or a magnitude of 15 newtons. And we're going to add that vector to one to the right, and clearly the size of the arrow tells us that its magnitude is larger, and it's going to be 35 newtons. So although we're adding vectors, we don't just add those two values together. We don't add 15 and 35 to get 50. That's not right. So the confusing thing is that if they act in opposite directions, even though you're adding vectors, you subtract them. So the answer to this for the resultant force is clearly going to be acting to the right, and the value is 35 minus 15, which will give you a resultant force of 20 newtons. So let's have a look at a vertical example. So I'm going to start off with a vertical force acting down. Let's say it's worth 125 newtons. I'm going to add that vector to one that's acting vertically upwards. And again, clearly larger, and therefore the magnitude will be larger. Let's say it's worth 400 newtons. So we're going to be adding these two vectors together. But because they act in opposite directions, it means we subtract one from the other. So clearly the resultant force is going to be acting in the upward direction because 400 is larger than 125. Subtract 125 from 400, we're going to get 275 newtons. So the resultant force is 275 newtons acting upwards. So let's have a look at vectors in two dimensions, and these are quite complicated compared to vectors in one dimension. We just simply can't add them together. So we're going to start by looking at a vertical force. And we're going to be using a scale here. So you notice that there are all the squares on there. I'm going to say one square is a centimetre, and that each centimetre then is worth 10 newtons. Usually you get given those scales in exams, so just pay attention to what that scale is and make sure that you use it. So we're going to measure the length of that arrow, and it's 11 centimetres, so that makes it 110 newtons. I'm going to add that vector to a horizontal vector. I'm going to measure the length of that. It's 15 centimetres, which means it's 150 newtons. So we're going to add those two, and it's not as simple as 150 plus 110 or 150 minus 110, because they're not acting in the same plane. One's horizontal and one's vertical. So we've got to do something different. And we're going to use the parallelogram method. And what that involves is making a parallelogram out of those two vectors, and this is how you do it. You select one of the vectors, and you draw a vertical line that's parallel to this vertical one. So we've started off, we've got two vertical sides to our parallelogram. And we're going to complete the parallelogram by drawing a line that's parallel to the horizontal blue vector. So we move a parallel line all the way up to the top, and we've completed our parallelogram, or in this case a rectangle. So the origin of the vector is the bottom left-hand corner, and its final position is in the top right-hand corner. So we draw an arrow from the bottom left to the top right to represent the resultant vector, or in this case the resultant force. And what we can do now is we can measure the length of that. It's 18.6 centimetres, which means it's 186 newtons when we apply that scale to it. And what will also happen is that you might, on occasions, be asked to measure an angle as well. So you need a protractor to be able to do that. And you might be asked to measure a bearing, or measure an angle from the horizontal or from the vertical. So be prepared to be able to do that as well. So let's have a look at a slightly more complicated one where they're not at right angles to each other. So here's our first vector. Let's measure the length of it. Well, using the same scale, if the length's 13.5 centimetres, that means we've got a vector of 135 newtons, or a force of 135 newtons. And we're going to add that vector to this blue one. And we measure the length of that. It's 12 centimetres, so it's 120 newtons. And we're going to complete the parallelogram again, so use the same method. So with the red one, we draw a line that's parallel to that, and add it onto the end of the blue one. And we do repeat for the blue one, and we draw all of the parallel line to the blue one at the top of the red vector. And now we have our parallelogram. Now the origin is in the bottom left-hand corner, and it's completed in the top right-hand corner. So we draw an arrow from the bottom left to the top right. That is our resultant force. And if we measure the length of it, 20.2 centimetres, that tells us that we've got a resultant vector of 202 newtons. Once again, you might be asked to measure the angle, an angle, using a protractor. That might be to the horizontal or in terms of a bearing. So let's have a look at another example. Slightly different. We're going to have the origin in a different position. So we're going to look at this vector. We're going to measure the length of it. We change the scale though, so be careful of that. So 8.5 centimetres, but the scale is 1 centimetre, which represents 5 newtons. So 8.5 centimetres is the equivalent to 42.5 newtons. So what we're going to do with that is add this blue one on top of it. So we measure the length of that, and we get 8.85 centimetres, quite precise. And that's going to give us a force of 44.25 newtons. We're going to add those two vectors together. And even though the origin is in a different position, we still apply the same rule. We're still going to draw this parallelogram. So we draw a line that's parallel to the red vector, and we draw that all the way down to the end of the blue vector. And we repeat it with the blue vector, with a line that's parallel to the blue one, all the way to the end to complete our parallelogram. Now this time the origin is in the top right hand corner and it's completed in the bottom left hand corner. So drawing an arrow from top right to bottom left, it represents our resultant force. And if we measure the length of that, 14.6 centimetres, that gives us a resultant force of 73 newtons. And once again, you might be asked to measure an angle, a bearing, so you'll need a protractor to be able to do that part of the question. So I hope you found that useful, and I hope that you will join us again on Spiral Physics Education and make use of the channel to improve your understanding of physics and improve your grades in time for your exams. We'll see you next time on Spiral Physics Education. Goodbye.